Okay, so now we can start. Yeah. Okay, so hello everyone. I'm Edi Tribaskoro, and it's a pleasure to welcome you all back to the Combinatoric to the series. And it's great to see you. I think I see so many familiar faces here. And can you believe it that we've been running this series for 4 years now? And today marked the very first edition of our fifth year in 2025. First off, a huge thank you to all of you for your enthusiasm and the commitment to this event. And we started this series with the goal of creating an engaging academic atmosphere, especially to support research and development in combinatorics and graph theory in Indonesia. And it's amazing to see how far we've come together. And I, I, I'd also like to give a big thanks to the Department of Mathematics, Faculty of Mathematics and Natural Sciences for their continuous support in making this series possible. And today we have a very special guest, Professor Slamin, actually our best friend. And I'm sure that many of you already know him well. And he's a leading expert from Universitas Jember, Indonesia, and his work in graph theory and combinatorics, particularly in Moore diagram, graph labeling and coloring, computational graph theory, and their application. And this has been a major source of inspiration for researchers in the field. And his talk today, titled The Role of Graph Theory in Machine Learning, promises to be both exciting and insightful. And of course, we are in a great hands as the session will be chaired by Dr. Renovia Simanjuntak. And before we get started, I also want to acknowledge the amazing organizations that have made this event possible. First, the Combinatorial Mathematics Research Group from Institut Teknologi Bandung. Second, the Indonesian Combinatorial Society. And third, the Center for Research Collaboration on Graph Theory and Combinatorics in Indonesia. All right, that's enough from me. Without further ado, let me pass things over to Dr. Rino, who will be officially kick off the today's session. Enjoy the lecture, everyone, and thank you.
Thank you, Pak Edi. Before I introduce our speaker today, should we take a picture first? Or?
Yes.
Okay.
Good idea. Yeah. Thank you.
So maybe please open your camera. Yang ambil siapa ini?
Saya juga nanti.
Oh, iya. Kasih aba-aba ya, Pak.
Ya. Okay, good. Yeah. Okay. Okay, now the first screen. And now the second screen. Then next, the third one. Okay. Yes, that's all.
Okay, thank you, Pak Edi. Thank you, everyone. So let's start with our Combinatorics Today series. So our speaker today is Professor Slamin. I will share my slide. Can you see it? Okay. So our speaker today is Professor Slamin from Faculty of Computer Science, the University of Jember in Indonesia. Professor Slamin graduated from the University of Jember, Universitas Jember, for his bachelor degree in 1991. And then from the University of Tasmania for graduate diploma in mathematics. And then he continued his study in the University of Newcastle, Australia for master and PhD, which he finished in 2002. Professor Slamin started to work in Universitas Jember since 1992 as a lecturer, and then he became the deputy head of Computer Center in 2002, and then the dean of Faculty of Computer Science for 9 years, Pak Slamin.
Yes.
Betul ya, for 9 years.
Almost.
And
Yeah.
now he is the vice rector for academic student and alumni affairs since 2020 until today. Professor Slamin was also chair for the Indonesian Combinatorial Society. So that was after Pak Tribaskoro. And his research is in graph theory, and I think a lot of applications in graph theory also. And in this area of research, he already published 112 research articles, which is indexed in Scopus. So this is the timeline of his academic appointments that I took from Pak Slamin's website. So you can see, actually, Pak Slamin also trained in ITB Bandung. So with us in 1994 for basic science bridging before he went to Tasmania. Okay, so without further ado, I would like to invite Professor Slamin to present his research, which is very interesting, I think, the topic, which is the role of graph theory in machine learning. Silakan Pak Slamin.
Okay, thanks, Bu Rino, for the very nice introduction. First of all, I would like to thank Professor Baskoro and Mathematics Department, especially Combinatorics Research Group in ITB, who is inviting me to share in this Combinatoric to the series. And of course, thank you also for Indonesian Combinatorial Society, because they sponsor or they support these activities. And of course, thanks to all participants who are joining this seminar or this Combinatoric today's series. I think I'm a bit nervous, because I thought it's only from Indonesia, but there are many our colleagues from overseas. So I think I have to speak in English instead of in Bahasa. But sometimes maybe I have to mix. If it is very hard for me to speak. Okay. Today I would like to talk about the role of graph theory in machine learning. Okay, I have to disclaimer that I'm not expert in machine learning. But my research in graph theory. The motivation why I want to talk about this topic is actually nowadays you know that artificial intelligence, data science, and machine learning is become very big issue, a very interesting topic, to do. I mean to take some research, for that. So that's why graph theory, especially in Indonesia, doesn't take part to do some research in machine learning, especially I think sometimes everybody now here is like just not moving around. Yeah, it's like very enthusiastic in graph theory as a theory. Yeah, so that's why I'm probably because also my background. I mean, not my background, my home base. Yeah, to be a lecturer in the computer science. Sometimes I have to do some many things related to computer science. So that's why I'm trying to talk about this topic today. Yeah. So basically, I will give some motivation. Yeah. For us, for all of us, not just for me, but for others, we have to think about the application of graph theory, especially in this recent topic, yeah, in computer science. Okay, this is the outline of my talk. I will start with some motivation and introduction. Maybe some of you, of course, already know about this introduction, but I assume that because we learn together, so that's why we have to recall, yeah, some definition of the topic that I want to talk today. And then I will continue of the role of mathematics in general, yeah, especially for machine learning. And of course, we will focus on the role of graph theory, yeah, why graph theory is used many than the others topic in mathematics, yeah, in machine learning, yeah, and then we will continue about graph based model for machine learning, because actually there are many type, many categories that we use for machine learning, especially that we use graph as a model. Yeah, and then I can conclude about the key aspect of this topic today. Okay, I think we will start with the big topics, yeah, which is data science. I think everybody know about data science. Why I have to start with data science? Because most of us are mathematicians, yeah, and we know that you can see from the picture that there are many parts, there are many field of area in mathematics are used to support data science. So that's why data science is defined as a combination of various fields, yeah, in statistics and computing, yeah, basically mathematics, yeah, as well, in order to interpret data for decision-making purposes, yeah, sometimes for predicting as well, to diagnose anything, yeah, sometimes, yeah, and also to do, yeah, basically decision making, yeah. Okay, this is data science. Next, this basics, yeah, this actually big data is used, yeah, to develop artificial intelligence. Of course, artificial intelligence will use big data, not just the algorithm, yeah, not just the machine that's embedded in that artificial intelligence, yeah. But you know that's with data science, artificial intelligence allow computer and machine to simulate human intelligence and problem-solving tasks. Of course, the computer is not intelligent if there are no data, yeah, and information. So that's why apart from algorithm, yeah, apart from formula and other stuff, I think data is take a very important role in this task, yeah, in this artificial intelligence, yeah, and the data used with the algorithm, yeah, with the technology used to solve the problem or solve the task that is given to that computer, yeah. And the ideal characteristic of artificial intelligence, it is its ability to rationalize and take action to achieve a specific goal, like human, yeah. Okay, and the next one, inside artificial intelligence, I mean, we know that we have to have like machine learning, yeah, to learn, yeah, to expand, to explore, to predict, to do anything, yeah, to solve the problem, yeah, that's focused on algorithm that allow computer to learn from and makes prediction or decision based on data, as I mentioned before. Yeah, so because we are mathematicians, so I think it's a good idea to put this relation, yeah, between machine learning, artificial intelligence, and data science in a set, yeah, and you can see that the biggest one is the data science, yeah, and then inside data science we have artificial intelligence, and inside AI we have machine learning, yeah, and I already mentioned before that some of them have different tasks, yeah, but they all together, yeah, to solve some problem or to make some decision, yeah. So I think everyone get the idea of this slide, yeah. Okay, now the role of mathematics in machine learning. You know that I think there are many opinion and many idea why mathematics is become very important in machine learning. I just put three of them. The first one, we know that mathematics is essential to machine learning as a concept. Yeah, so we know that we have a lot of pattern in mathematics, and we will identify the pattern. We even generalize the pattern to get some general formula. Yeah, and of course, can use mathematics to develop an algorithm. Yeah, so that's why we call it mathematics is essential to machine learning as a concept. The second one, you know that mathematics is the language of machine learning. Yeah, so that's why even we have different languages, yeah, from over the world, yeah. But you know that mathematics is unified us. Yeah, mathematics unify us because mathematics is general language, even for the machine. Yeah, so that's why. Mathematics is enabled to develop the algorithm, analysis of data, and of course to optimize the model. Yeah, I mean we can develop model to optimize some problem. Yeah, to be solved. Okay, and the third one, then mathematics has become the backbone of machine learning. Yeah, because many area of mathematics used in machine learning. Yeah, so that's why mathematics provide the theoretical foundation and tool, yeah, for understanding, designing, and even optimizing machine learning algorithm. I think this is clear, yeah, for us. Yeah, and now this is, I think, everybody now. So you can find it somewhere, yeah, in Google, in other AI. Yeah, what is field of area in mathematics supporting machine learning? Yeah, for example, in linear algebra, we know vector and matrices. We know eigenvalue and eigenvector. We even know singular value decomposition. Yeah. And in calculus, we know differential, we know integral. Yeah, that's all used in machine learning. Yeah, and of course in probability and statistics, they even very clear topic. Yeah, very clear field of area in data science or in machine learning that use, yeah, to analyze data, to do some prediction and other thing. Yeah. And numerical methods, yeah, of course, we can use metric factorization technique, yeah. Also some approximation technique, root finding algorithm for model tuning, yeah. And discrete mathematics, of course, most of us here is work in discrete mathematics or even teach discrete mathematics, yeah. We have Boolean algebra, combinatorics, set theory, and other things. And information science, of course, we have entropy and mutual information, yeah, and data compression technique, and so on. And how about graph theory? yeah, about graph theory. This is our most of us, yeah. I think interesting in this topic, yeah, or in this area. I think most of us work in this area, and even most of us are professor in this area. So that's why I mean, how about graph theory? I mean, what is the role of graph theory to support machine learning? Yeah, the first one, of course, we have like graph neural network. Yeah, usually this neural network is used to solve some problem. Yeah, and mainly it is used for social network, recommendation system, and bioinformatics. Yeah, and other thing, of course. Yeah. And we know we have a shortest path algorithm. Yeah, no, we know that it is very, very useful. Yeah, used by, for example, Google Map. Yeah, to find shortest path. Yeah, to find optimal route. Yeah, using Dijkstra and other algorithm. And of course, you also have spectral graph theory, which is quite difficult. Yeah, but it is used in community detection and classification, especially data classification. Okay, and I think everybody know here. I mean, know this know graph. Yeah. Why? What is graph theory? I don't want to talk many about this. I mean this slide. Yeah, because everyone know that. But you know that a graph is also a general language for describing and analyzing entity with relation or interaction. So that's why we need vertices or nodes and line or edges, yeah, to describe the entity and to analyze the relationship between them. Yeah. Okay. And we know usually we talk how to represent many objects in the world. I mean, using graph. Yeah. How about graph itself? Can we represent graph as other, yeah, as other formula or as other object? Of course, this is the example. We can represent a graph as the geometric what's called form. Yeah. For example, you can just what's called put some highlight in the box that if it is like there is connection between 1 and 2, yeah, we can just what's called, we can just draw that graph using this square, yeah, or cell, square that contain a cell, yeah, or even we can just translate into adjacency matrix. Yeah, this is usually used, especially in the computer. Yeah, so that it's easier for a graph if we translate into something related to number, either it is a matrices, vector, and other. Yeah, such as adjacency list and others. Okay, and why graph theory is used for machine learning? Of course, you know that's in this world we have a very complex data. Yeah, there are many. Yeah, that's why we talk when we talk about big data. Of course, it is complicated. Yeah, so that's why graph provide flexible and intuitive way to model, yeah, a relationship between entities. Yeah, and of course, graph is also leveraging structural information. Yeah, graph-based method can capture the underlying structure of data and leading to more accurate and insightful model. Yeah, and then the last thing is about not least, of course, scalability. Yeah, graph neural network are designed to handle large-scale graph data efficiently. Yeah, and of course, why graph theory? Yeah, because we love graph theory. Yeah, that's the most important thing. Yeah, I think without that we are very lazy to do something using graph. Yeah, just I think the most reason. Yeah, the most related reason why we use graph for machine learning. Yeah. Okay, this is some example. I took this from. Actually, there is very good video and slide if you want to learn graph in machine learning, given by Professor Ure, yeah, I think it's from Stanford University, yeah, is very very. I think I joined that lecture, yeah. I mean, watching his video and learn from his slide, yeah. I think it's very good for us, yeah. If we want to learn a graph in machine learning, I think it's very detailed, very with some example, yeah. And yeah, it's not quite easy for beginner, yeah, to understand, but I think it is very good. Good slide, very good lecture. You want to learn about machine learning using graph model. Okay, you know that I know, especially for you all here, I think many people usually represent anything in the world using graph. Yeah, but I just want to remind you, recall, yeah, about the graph representation, because we have a lot of things. Yeah. Yeah, this is to make us become what's called love a lot. Yeah, love a lot to graph theory. Okay, the first one is even graph. So we can just event. Yeah, you can represent some event, some activities. Yeah, either this in the sport or other activities. Yeah, using graph. Yeah. And of course, we usually use this example, computer network. This one, yeah, this is pathway. Yeah, I'm sorry, I have to explain some basic idea. Yeah, and food webs, particle network. Yeah, and also underground network. Many objects. Yeah, many real word. Yeah, that can be represented using graph. Cost social network, economic network, communication network, even there are so crowded there. Citation network, yeah. Usually we can just see our collaborator, yeah, our co-author, and even some topic in common, yeah, with other authors. We can use this graph, yeah. Of course, internet, yeah, that we usually use, and network of neuron, yeah. And knowledge graph, yeah, which is also part of used for machine learning, yeah, and regulatory network, scene graph, yeah, to see some theater, yeah, some movie, yeah, code graph, yeah, even coding in computer science and programming, we can use graph, yeah, to represent that. Molecules, of course, even the 3D shape, yeah, in graph drawing, yeah, we use graph. And what we use in machine learning, yeah. Actually, there is tasks in machine learning that we can solve, yeah, either using link level prediction, yeah. So it means that we use the edge properties, yeah, or we can just use node, yeah, we call it node level task, node level prediction, yeah. Just it depends on the classification of nodes, yeah, and even the whole graph, yeah, which means graph level, we can use all of them, yeah, to solve some problem, yeah. For example, okay, this is the different type of task, yeah. For node level, you can, as mentioned before in the slide before, we can just consider the vertex of the graph, yeah, or some vertices of the graph. You can see and we can identify what's the node property look like, yeah. And also you can consider as the edge level, yeah. You just use where we can focus on the edges, yeah, on the arcs or on the connection, yeah, or relation, yeah. And of course, the subgraph, yeah, we can combine them, and the biggest one is the whole graph, yeah. Okay, this is the example, yeah, for node level task, you can see that the task is to classify the nodes. Yeah, just forget it about the classic coloring. Yeah, I mean perfect coloring. Just this is any coloring. Yeah, suppose that the graph on the left, yeah, of the slide is like random coloring of graph. Yeah, you can see we have like red and green color, and it is not clear what the color should be in the gray. Of course, you can answer, oh, of course, the gray color is matched for that one. I mean, not that one. Yeah, I mean, if you consider to color the grid vertices by green or red, yeah, you can see the structure of the graph, and also the identification of the green vertex and red vertex. So you'll end up with, I mean, using machine learning. Yeah, the machine will learn about that graph condition. Yeah, graph structure. Yeah, especially the nodes. Yeah, or the vertices, and then we'll end up, for example, like the graph on the right side of the slide. Yeah, for example, some of them is green, and some of gray vertex become red. Yeah, for example, there are two become red. Yeah, and two become, or three become green. Yeah. Okay, this is another example. If we want, I also take this one from Professor Yure. Yeah, Alu Reflect. I forget the name for this one. I think Leskovec. Yeah, Leskovec from Stanford University. And I think for graphlet, for example, we will find factor of rooted subgraph at given node. For example, we have this graph G, and consider one vertex U in that, and we will find all possible graphlet on vertex U up to 3 nodes. Yeah, and we will find the graphlet instance of nodes U by we have like, actually this is the output. Yeah, we need the output by using factor. For example, from type A we have 2, from type B we have 1, from type C we have 0, and from type D we get 2. And then we will use this factor to solve other problem, even to find that graphlet as well. Yeah. Okay, and the next thing, this is the some application, some example for that. Yeah, for example, we want to predict a protein, yeah, 3D structure based on solely on its animal sequence, and we want to predict the 3D coordinate for this protein. Yeah, and we'll find, for example, this thing. Yeah, if we compare with the between computational prediction and experimental result is not quite big different. Yeah, it's almost the same. Yeah. Okay, this is the link level. Yeah, the link level task. Yeah, and usually we want to predict missing or new or unknown link based on the existing link. I think some of us use this one, yeah, to predict something, especially for, I think, for matching, yeah, for recommendation system, yeah. If you want to buy something, yeah, what is the most recommended thing, yeah, either shoes or clothes or other thing, yeah, that you want to buy. Yeah. And at that time, the node pairs, yeah, are ranked, and top K node pair are predicted. Yeah, and the goal is make a prediction for pair of node. Yeah. Okay. This is an example for that. If you want to recommend item for user, probably we make like, yeah. And usually I think everybody have experience with that one. If we try to find something in online shop, yeah, in online shop, yeah, online shopping, suddenly in our Facebook, in our Instagram, or other social media will like there is some advertisement over something that we want to buy. Yeah, even we already buy it. Yeah, so I think that machine learning work for that. Yeah, for that social media. Yeah, to advertise something. Yeah, I think this is part of recommendation system. Yeah, because yeah, they will give some brand, yeah, certain brand for us to buy. Yeah, okay, and this is other example. Yeah, when we want to predict the side effect if we consume or we take some medicine, yeah, especially more than one, yeah. Sometimes if they are we consume together, yeah, in one, yeah. I usually take some medicine, at least 4 kind of medicine a day, yeah. But I haven't. I mean, I don't know what is the side effect for that one. But I think I need to use Graf, yeah, to know what is the side effect for that two medicine if we take together in one time, yeah. And the goal is how likely, for example, simvastatin usually we used it to reduce our cholesterol in our blood, yeah. And ciprofloxacin, for example, when taken together, break down muscle tissue, yeah, because I think muscle is influence or usually is depend on the protein interaction. So that's why they use like protein, yeah, to interact each other. Yeah, for example, yeah, you can see that for if the one that's in the triangle shape, the node in the triangle shape is represent drug, and the circle shape is represent protein. So you can just see that, yeah, the what's called the correlation between them, yeah, the interaction between them, yeah. And another, this is the graph level, so you can just mix a prediction for the entire graph or a subgraph of the graph. For example, if you want to see this, yeah, this one is I just modified what Professor Jure used for their example. For example, if you want to go from Jember to Bandung, yeah, you can use usually Google Map. If you go by car, at least we need 11 hours, yeah, 5 minutes, for example. And of course, we can predict how long we will get Bandung, or where the traffic is crowded and where is good. Yeah, for example, by using this one, we represent not as a route segment. It's the connectivity between route segment, and then the goal is we predict the time of arrival. Yeah, and then we use this. I think Google Map use this algorithm. Yeah, this machine using graph neural network. Okay, now we continue to modern machine learning. Yeah, and usually, yeah, you can find it anywhere. I think modern machine learning toolbox is work like, yeah, we can start from some input layer, and we have a hidden layer, another hidden layer, and then we will get the output. So that's why because it's too deep, we call it deep learning, yeah, toolbox. Yeah, it is designed for simple sequence and grid. Yeah, and then this is the journey of the graph machine learning. Yeah, start from knowledge graph. Yeah, usually in knowledge graph, we find the pattern that you are looking for in connected data. Yeah, and then we use unsupervised machine learning technique to identify the association, the anomalies, yeah, and the trend, yeah, of that graph. Either you can consider from the node, yeah, from the vertices, from the edges, or from the whole graph. Yeah, and then we use graph native machine learning. Yeah, use embedding. Yeah, to learn the feature in your graph that you don't even know are important yet. So that's why sometimes we focus on the theoretical stuff, but of course we know that in the future there will be some application for the one that we have done before. Yeah, I believe that. Yeah. But we have to do so. Yeah. Okay. Then all the thing is trained in the graph supervised machine learning model to predict link, labels, and missing data. Yeah. Okay. And this is the type or categories of graph machine learning taken from Java Point and other resources. Yeah, other source. Yeah, for example, most of machine learning use graph neural network. Yeah, because this is designed to process graph structure data. For example, graph convolutional network, graph attention network, and graph Shage. Yeah, and also graph-based semi-supervised learning when label data is scarce. Yeah, graph-based methods propagate label through graph structure. For example, label propagation algorithm. Yeah, and the other thing is graph-based anomaly detection, identify unusual pattern in network graph. Yeah, for example, page rank, graph auto encoders, random walk based methods. Yeah, we usually use this one to detect frauds. Yeah, if there is some fraud in some transaction, and graph-based clustering. Yeah, usually it used to find communities or cluster in graph-based data set. I think is good for to social network analysis. Yeah, for example, spectra clustering, Markov clustering, affine methods, and other thing. And the fifth one is graph-based reinforcement learning. Graph are used to model state space for interaction, for example, deep Q network on graph, and because graph-based recommender system use graph representation to improve the recommendation. Yeah, for example, graph collaborative filtering. Yeah, okay. This is the differences between graph machine learning and conventional. Well, I call it conventional. I mean, general machine learning. Yeah, other machine learning. Yeah, we can just summarize in this table. Yeah, we can see from that aspect the data representation in graph machine learning we use graph structure. Yeah, nodes, edges, or even the whole graph. Yeah, but for other machine learning, usually use tabular, image, stack, or sequential data. Yeah, sequential data, and the relationship, especially the modeling relationship, graph machine learning use explicitly model relationship. Yeah, because it's more clear. I mean, we can see that how they relate. Yeah, because we can draw the graph. Yeah, we can see that graph. Yeah, and in conventional machine learning, ignore relationship unless encoded. Yeah, sometimes we don't know behind the screen. Yeah, and the techniques used for graph machine learning use like graph neural network, use random walk, graph kernel. Yeah, for conventional machine learning, we usually use linear model tree. Yeah, especially decision tree, which is also graph actually. Yeah, some supporting factor machine. Yeah, and conventional neural network and recurrence neural network, and so on. Feature engineering derived from graph structure. Other machine learning use manually engineered. Yeah, task is node, links, graph, classification, community detection, and for other machine learning, usually use classification, regression, and clustering. Scalability can be challenged for large graph, generally most scalable, because we don't have to draw using graph. Interpretability, we can it is challenging to graph complexity, and some model are interpretable. Application, because we have a lot of some application for that. For example, social network, drug discovery, fraud detection. On the other hand, for other machine learning, we can see the image recognition, natural language process, predictive modeling, and so on. And the learning type for graph machine learning, we use transductive or inductive, but for other machine learning, primarily or mainly using inductive. Okay. Now I want to talk about some application, example. For example, some graph machine learning used to solve to analyze social network, to do some citation analysis and bibliometric, fraud detection, semantic web and linked data, recommendation system, and other things. Actually, now I'm start to working for application in agriculture. I think we will do some research, including some collaboration research, to solve some, to manage agricultural big data. I think because in Jember, most of area is agriculture. I think most of area in Indonesia actually, especially the government have some policy for the food security and other things. Okay. This is for social network analysis. And we want to analyze between, the connection between individual in social network to identify communities, influencer, and information flow pattern. You can see that from how the intent, how the very frequent interaction between them. So we can see from that connection, from that what's called the intention. You can see, this part is most of us is from Hawaii, most of us is from Samoa, for example. Even probably in this graph theory, what's called networking. If someone, I think you can see from that citation analysis. Next slide, I think. And this one, you can, where can we analyze? But I tried to find in Sinta, but I couldn't find. Last time I can see how close we are. Especially the authors of the paper in Indonesia and overseas. Because we have application. Probably someone here find that. Last time I can find that graph, that's connecting between Ph.D, Bukiki, Burino, me, and other collaborator and other author, which is so very nice picture, very nice graph in that, and we will find how close we are, in that Sinta, especially how often we are working together, producing joint paper and others, but in this citation analysis, we usually analyze citation and references in this research paper to understand the influence and relationship between scientific works. So you can see here, actually, chemosphere, there are very strong relationship with environment, science, technology, for example, chemical society, and other things. You can see from this whether the graph is dense, or sparse. I think it's depend on the how often we are working together or relate each other. Okay. This is for fraud detection. Usually we can see the anomaly of the pattern, of the graph, whether it is in that node or vertices or in edges or even in that graph. I think usually there are many kind of route, yeah, detection, for example, like sometimes someone pretend to be me, yeah, and then send WhatsApp, yeah, message for to call my friend, yeah, to ask or to borrow money. I think it's common in Indonesia, but some of them I still believe. Yeah, I don't know why. Yeah, I think we can see even without graph, we can see there is some anomalies in that. Yeah, sometimes even like they send the student that I'm asking for, you know, like for what's it called? In Indonesia, we call it pulsa, yeah. I think it's the same, yeah, because I'm a professor and vice rector ask for student to bring, to buy me like pulsa, yeah. What is pulsa in English? Well, like whatever, yeah. Okay, this is fraud detection, and this is the semantic web. Yeah, we can create link data and semantic web representation using graph structure to improve data integration and interoperability. Yeah, and enable meaningful querying and navigation across multiple data sources. Yeah, you can see that. Yeah, from the web. Yeah, either this this is it's about music, social network, politics, for example. We even know like if there is like a trending topic in social media, yeah, we can find it very easily, yeah, in that. And this is the recommendation system, yeah. I think, yeah, some of us is very often find this recommendation system, yeah, especially when we want to buy something. Yeah, I think it's also good for us. In some online shop, yeah, online shopping, they provide some like a comparison, yeah, between some product, so we can compare which one is better or which one is cheaper and which one is what's called stronger, for example. Yeah, sometimes we need some parameter, yeah, and then we just choose that parameter, and also it's depend what is our our focus, yeah, our recommended path. The weights of that parameter should be the biggest one, yeah. For example, if you consider about the price, yeah, about the quality, about the rating, yeah, it's depend on us. I think that's system will provide some information so that it will end up with some recommendation for us. That's the good the good thing for you. The good what's called the good computer, for example, to buy. Yeah. Okay. And in NLP, yeah, and natural language processing, yeah, I think we can. That's usually, used very common in machine learning. Yeah, enable machine to interpret, to generate human language, transforming massive amount of text data into valuable insight and automating various tasks. Yeah, modeling relationship between word or sentence in a text to improve tasks like sentiment analysis or text summarizing. What I talked about previously. Yeah, you can see when we have some general election, we can find sentiment analysis in that, especially after debating. Yeah, and also you can see social media monitoring. Yeah, and language translation. Even usually we use that one. Yeah, I think this is the most machine learning that we use, yeah, nowadays. Yeah. Okay, bioinformatics. I already explained the interaction between protein, drug, and protein. Yeah, even using this machine learning, we can produce a new drug. Yeah, new medicine. Yeah, to solve, for example, side effect influenced by, as an effect being consumed two drugs, yeah, in the same time. And agriculture, this is what I'm working. Recently, we're still working for that one. In precision farming, to optimize crop yields using data from sensor and drone, pest and disease detection, yield prediction, automated harvesting, which is usually use robotic and other smart machine. Okay, and actually we can use Neo4j, because I think it's good as well, especially graph algorithm in a new 4G, you can have the property of graph, either we consider the centrality, usually it's used for peak strength. Usually works for centrality, we will find the radius, eccentricity, and other thing, also means metric dimension, to see the closeness radius, closeness and other thing, the degree itself, and clustering, usually we can cluster, we can see that graph by considering the subgraph, the property of the subgraph, so we can just cluster that that subgraph, and of course path finding, which is usually used that one, recently. Now, how about graph database? Of course, a graph database is a digital warehouse, that store data and configure the information into graph, and graph database, of course, play a very important role, in efficiently storing and querying data structure. Sometimes labeling is very important, to store graph, and also graph database was originally designed to store network, basically. That is the connection between several elements such as people, place that may visit, we have like touch graph at the time, I couldn't find that application anymore. Usually in Facebook we have touch graph, and we can just draw our friend, in one graph. This is very beautiful, and also good, so we can find what is the diameter of that graph, how close we are, and how far we are with other person, especially in the globes, and also the thing we might use, okay. This is the key aspect of graph database role, of course, for native graph structure, I think this is the very important keys in that. Efficient data retrieval, we can find the data, we can take the data, or even see the data, index-free adjacency, scalability, real-time insight, flexibility, complex query, use case, it's easier if we draw by graph, to what is called to represent that use cases and other thing. Okay, this is the conclusion, and we know that graph theory provide a powerful framework for machine learning, I think we just need to explore that deeply, enable. So I know that before the machine learn, I think we have to learn first, enable modeling and analysis of complex relational data, and graph based method are transforming machine learning application, usually we use conventional machine learning or other machine learning, but now you can use graph based model, open up a new possibility for featuring engineering and algorithm development, and has a wide range of application, across diverse domain. That the good thing about graph theory. Even without machine learning, we use graph for other thing. Okay, I think that's all. Thank you very much. I will give back to Bu Rino. Thanks, Bu Rino.
Thank you, Pak Slamin. for a very interesting presentation. And I think some of you already written some questions in the chat box. But I think before we move to the question and answer session, Pak Edi will have some songs.
That's good.
So, Pak
Okay.
Slamin, maybe you can read the question.
Yes, yes.
Okay.
I also
Pak Edi?
upload the slide. Yeah.
Okay.
In the chat.
Okay. Okay, good. Yes, because this
Okay.
series is actually mathematics and music combined. So
Okay.
I am now sharing some song for us. Yeah, and this song actually is not song; it's instruments, instrumental music, and play with the angklung instrument. So, okay, the title of the song is Manuk Dadali. Oh, just a moment. Salah. Mana tadi? Okay, try again. Okay, good. You hear it from? You know? Okay. I hope you enjoy. Oh.
Okay, thank
Oh,
you,
of
Pak
course,
Edi.
we are enjoy it. Very good song. Salamin.
Yes, a song from West Java, Pak Slamin.
Yeah, I know. I'm listen very often.
Okay.
Mm.
Okay, Pak Slamin. So there is a question in the chat box from Raden Aurelius, but I think he wants to ask the question directly to Pak Slamin. Please, Aurelius.
Sure. Thanks for the chance. I have some question about this topic, but before I ask this question, I have to give some disclaimer that I'm not quite familiar with graph theory. So apologize if this question might sound quite trivial for you. So the first one is, based on your knowledge about graph theory, is there any possibility to develop a novel or at least maybe modify a graph machine learning framework that can work with more classical tabular data? Like for instance, we're talking about finance data or maybe spatial data or etc. And secondly, is there any specific hypothesis test, like maybe statistical related tests, like we usually do in statistics or mathematics when we working with regression? There are some like normality tests or linearity tests, or maybe there are some graph related tests that you have to fulfill when we working with graph machine learning. So that's all my questions. Thank you.
Okay. All right. Langsung, Mbak Rino.
Ya,
Sorry.
silakan Pak.
Yeah, before I forget, I think it's a good idea to directly answer the question. Ini Mas Raden ya. Okay. Thank you, Mas Raden, for the question. I think this is not trivial question. Yeah. This is a very good question. Yeah. I think in my knowledge, because you are asking about my knowledge, about graph theory, related to the machine learning, of course, there are a lot of potential, thing to do, something new, especially, and that's why I present this topic today.
我知道，我还没出去呢。
Even I'm not expecting in machine learning. I only work in graph.
我说我知道，我说我现在没有出去。
I think there is some leak in the Zoom. I will continue my answer. If you want to understand about my English, I can switch to Indonesia. Don't worry, in bahasa Indonesia. But I will continue. That's of course, if we explore how good, what kind of application that can be used, graph, as a tool. There are a lot, even including in machine learning, because comparing with other, usually traditional machine learning model use like decision trees, random forest, deep learning model, and sometimes they use like tabular data, in the table, but graph theory use like approach, or model, to capture the relationship and the dependencies between the data, between the object, between the entity, I need now the difficult question is, what is the relationship between them? I think that's sometimes we have difficulties to explain or to formulate the interaction or the relationship between entities. Between, if you already know the entity and the relationship between them and what we have to do, usually using graph is easier. Probably when we talk is easier, but when we do, it's not as easy as when we talk. But I think, I believe that is easier comparing with other tool. And second question, I think to clarify my answer, there are many many possibility, many potential thing to do using graph machine learning. The second question is, I think, related to the I think I can see in that graph again, using graph machine learning, especially when we see the hypothesis test, and we want to work with with graph, with GML, with graph machine learning, I think we can use that to validate the model, to detect the pattern, as I explained in the example, and also to answer the statistical significance, of that machine, of that tool, I think we can see that. Yeah, we can. I mean, we can not guarantee, yeah, but we can assure that we can test that hypothesis is true. Yeah, so we can basically we can use some statistic key, yeah, in that regard, a graph-related hypothesis tests, yeah. For example, using graph density, yeah, testing, using that what I explained before, node and age level testing, yeah, hypothesis testing. We just consider, for example, you can see that when we, especially when we have like supervised machine learning, yeah. For example, remember I give a very earlier example when we want to color or change the color of the nodes, yeah, from gray to either red or green, yeah. Actually, we can just embed that machine using, for example, classic edge coloring, for example, yeah. And then I think it's easier. We can just test that hypothesis is true, that machine learning is working in that case. Yeah, I think that's all, Mas Raden. Is there any missing information that I haven't answered that? Ada yang
Yeah,
terlalu?
I think it's enough, sir. Because it's very
Okay, I
interesting
think you
answer
have
because
a very not just the graph machine learning, which is potential for us, but you are very potential to do some machine learning. Yeah,
yeah,
you know what
correct.
I mean. I think Mas Raden can work, especially for you. You are still young, you still have many energy, and other young student. Yeah, so that's why actually my motivation why I choose machine learning. Even it is not easy for me as well. Yeah, but if we want to do some to solve this problem together, work this topic together, I think we can find easy answer. Ya, ya. Makasih Mas Raden ya. Saya pikir itu pertanyaan yang sangat fundamental ya, sangat bagus.
Ya, terima kasih juga
Kayaknya
Pak.
kalau
Thank you.
pakai bahasa Indonesia lebih mantap ya.
Iya.
Sorry.
Iya, Pak.
Sorry,
Nanti
just
bisa.
kidding. Yeah, sometimes I have to think twice. Yeah,
Okay.
You know what I mean ya, Mas Raden ya. Okay.
Okay, thank you, Raden, for the question and also Pak Slamin for the answer. There is a second question from Bu Vini. Bu Vini, do you want to ask the question directly or should I read your question?
Yes.
Okay, silakan Bu Vini.
Halo Pak Slamin.
Ya,
Really
halo, Pak
interesting
Vini.
talk. Yeah, I think my question is similar to Raden's question. As for the people who is not really familiar with graph theory, how can we recognize problems that can be solved using or can be solved better using a graph-based algorithm?
Oke. Ini pertanyaannya fundamental juga, Pak. Sorry. Dan tidak similar sih sebenarnya. Oke, sorry saya menggerutu pakai bahasa Indonesia ya, biar yang lain nggak ngerti. I think this is very fundamental question as well ya. I think even without machine learning, I think we have to recognize the problem before we translate into graph. I think that's our first job to solve that problem. So that's why the first thing to do, even in manual, not machine learning, usually we identify the graph structure, especially if we what's called relate to the data set. That's what we have to do first. You already answered that. Should we identify the graph structure? Of course, this is the first thing to do. And then we so that's why I told you before, like we have to recognize first from that problem which one is node or vertex and which one is okay. After we identify the object or the entity with vertices, the next thing is what is the relationship between them. Yeah, so we can see after that we can see the structure of the graph. Then of course we can see. I mean, we can solve that problem, yeah, step by step after we know that. Well, in machine learning that use what's called graph model, actually not just graph neural network. Of course, we also have like other methods or other model. Yeah, I think I already mentioned before. So it's depend on that problem. You can use that model as well. For example, this is my favorite example. So that's why I mention very frequently, yeah, very often. For example, for recommendation system, I think we can use that one in that machine learning language. Actually, we can use link level or edge level. Yeah, so you can see that one. In that case, yeah, in that case, maybe we can just model that's what recommendation system, recommender system. So we can just use the property of the edge connecting, edge, yeah, the link. We just connected between the entity. So in that case, if it is clear enough, we make us sure that we use this recommender system, so we can use that. Yeah. And for other thing, for social network, for example, maybe it is good to use clustering. Yeah. For fraud detection, maybe we can just use the what's called anomaly, yeah, detection. Yeah, if there is something weird in there, sesuatu yang aneh lah. Kayaknya susah saya ngomong pakai bahasa Inggris ya. Jadi in conclusion, in apa ya? I'm so sorry for others. I think I want to clarify my answer in bahasa Indonesia, Mbak Vini ya. Jadi tetap sangat tergantung pada struktur dari data tersebut, dari masalah tersebut, yang kemudian kita modelkan ke dalam graf, gitu kan. Setelah itu baru kita pecahkan sesuai dengan masalah tersebut. Saya tadi ngasih contoh sistem rekomendasi misalnya, ya itu sebenarnya cukup pakai yang level sisi saja lah atau garis saja kan begitu. Kemudian kalau tentang anomali, hal-hal yang terkait dengan fraud, penipuan misalnya, ya pakai yang pattern recognition ya, yang anomali tadi. Bahkan untuk yang sosial analisis ya, medsos analisis, kita juga bisa pakai misalnya kalau itu terkait dengan komunitas, kita bisa pakai clustering. Gitu ya, Mbak Vini ya. Yang paling susah itu kan bagaimana memodelkan masalah tersebut ke graf, kan gitu kan? Itu yang paling susah gitu. Padahal sebenarnya semua bisa kita grafkan. Bahkan mungkin saya ulang ya, karena itu sudah lama sekali dan saya jarang sekali mention lagi. Bahkan saya pernah nulis di blog saya waktu itu, bahkan hidup aja juga seperti graf, ya nasib seperti titik, usaha seperti garis, kan gitu kan. Jadi hidup adalah graf, kira-kira seperti itu, apalagi bagi kita. Ya, so for the one who don't understand bahasa Indonesia, I just said that life is actually a graph. Yeah, destiny is the vertex, and what is called our effort is ages. Yeah, so we just combine them to make the life is beautiful. Yeah, so that's our job. Yeah, our task. Gitu Mbak ya, Mbak Vini.
Oke Pak,
Mbak
terima
Rino.
kasih Pak.
Thank you.
Okay, thank you, Vini for the question and Pak Slamin for very detailed answer and also philosophical answer
philosophical.
in some way.
Yeah.
Okay. There is also, I think this is the last question
Mhm.
from Ridwan Ahmad.
Okay.
Ridwan, do you want to ask? Or
Yeah. It's okay. If it is not
I
enough,
can
then
read.
I can. What?
Okay.
Is,
Okay, I will read the question. I would
uh,
like to ask a question. Are there research advancements or publications regarding graph theory and machine learning being used to solve optimization problem in the field of operation research, such as scheduling problem or vehicle routing problem? Okay, thank you
okay.
for the insightful presentation.
I believe there are lots, but I'm not searching that in that topic, in that application. But usually I also, I only find some application for agriculture, so that's why. But of course, I believe there are many, especially for scheduling system. I think Pak Mas apa tadi Mbak? Mas apa ya Mas?
Ridwan.
Ya Mas Ridwan.
Ridwan.
Ya,
Ridwan.
saya yakin banyak sekali Mas, tinggal nyari di Google dan di ResearchGate atau di Science Direct. Saya yakin banyak. Saya hanya fokus sementara ini pada bidang pertanian karena memang saya lagi ngajukan atau melakukan riset di situ big data tentang pertanian lah gitu. Apalagi sekarang ada kebijakan apa Mbak Rino, swasembada pangan ya. Lain-lain saya pikir itu relate. Tapi silakan Mas Ridwan ya, I think there are a lot of paper talking about graph machine learning for very diverse application. I think it's anything, including optimization problem and also operation research, also scheduling system, and other thing. Itu Mbak Rino ya.
Okay. Thank you, Pak Slamin. Okay, there is another one. Maybe this is the very last one, from Andi Rahadi. Pak Andi mau tanya langsung? Oh, I just read it ya.
Saya langsung jawab aja, Mbak. Ya, saya pikir semua bisa, Mbak, Mas Andi. I think all is very possible. But the main task, the first thing first to do, we need to translate that problem into graph. Either we will use graph-related metric, betweenness and centrality, especially centrality. I already mentioned how the type of machine learning, use for the property of graph. Either they consider about the centrality, about connectivity, about the clustering, it's very possible, Pak Andi ya. Itu Mbak Rino. Mas Andi. Ternyata lebih muda dari saya sambil mas saja.
Okay.
Okay.
Okay, thank you everyone for the question. Or maybe Pak Edi, do you have a closing question?
Ada song?
Or comment?
Okay, so
other song.
So let us thanks again to Professor Slamin for nice and interesting lectures. So this is good for beginning for this Combinatoric today series. So I think your lecture is nice and encouraging to young people to study more and more in graph and also in the relation to machine learning. Okay, so on behalf of the Department of Mathematics and Faculty of Mathematics and Natural Sciences, I would like to present you some certificate, Pak Salamin.
Oh, that's good.
Let me
Wonderful.
show you.
Thanks, Pak Edi. Thank you so much.
I prepared this.
Is there any ceremonial for that?
I prepared this certificates also
Thank you, Pak Edi.
with machine learning. So here,
So
this is the one. So again, thank you for being a keynote speaker.
But I think we need full screen, Pak Edi. Sorry.
Full screen.
Saya anu
Let
juga,
me-
saya agak narsis
Iya,
juga,
sebentar,
Pak.
sebentar.
Sorry, just kidding, Pak.
Let me hide first this. Okay. Yeah.
No, I'm just kidding, Pak Edi. No need. I already saw my picture there.
That's fine. That's fine.
Hmm.
I'll show you.
I think you can see the view and then full screen.
You
Yeah,
and
enter full screen.
Paling bawah, Pak.
paling bawah. Ya. Here.
See, that's much
Okay.
better.
Good. Yes. Okay. So this is your certificate,
Thank
Pak
you.
Slamin, as being a keynote speaker in our Combinatorics to the series, and also this one
Wow.
created by.
I think it's more handsome than the reality. Yeah.
Handsome, yeah.
Sorry.
Okay.
Okay.
So
The real
yeah.
one. Yeah.
So you can just put in a frame and put in your
Yes.
table. Yeah. So will be
Okay.
great.
So yeah,
Okay,
but I
so
need
I will
you send the file to me. Thank you, Pak Edi.
Yes, I
Terima
will
kasih
send,
banyak. Yeah, Pak Edi.
send you these two test certificate. Okay, so thank you, and I think this is we come to the end of this session today, Combinatorics to the series with Professor Slamin. And again, thank you very much to all of you for attending this series, and hopefully see you again in the next 2 months. Yeah. Okay. So terima kasih semuanya.
Terima kasih
Okay, bye-bye.
semuanya. Thanks all.
Terima kasih, Pak
Ya.
Thank you,
Slamin.
everyone.
Marian,
Sampai ketemu.
Thank you.
semuanya ya.
Prof.
Pak.
Cia,
Thank you so
thank
much.
you.
Wah,
Makasih
Halo,
Pak,
ya.
thank you, terima kasih.
Bye-bye.
Bye-bye.
Okay,
Bu
bye.
Leli, makasih Bu.
Ya, oke.
Wah,
Terima
ini
kasih
saya
semuanya ya.
kalau nggak gini nggak dipaksa belajar
Oke.
sama Pak Edi nih.
Ternyata banyak ini yang hadir ini. Ini fansnya Pak Slamin
Maksa.com.
luar biasa.
Ya.
Benar-benar nih.
Oke,
67
Tapi fansnya
hari
banyak,
ini,
Mas
ya.
Slamin.
Heeh.
Fansnya banyak.
Oke.
Ya, fansnya banyak Mas
Oh,
Slamin.
enggak
Mudah-mudahan
ya.
banyak yang
Artis
mengikuti
beliau.
nanti ya.
Kayaknya saya bikin pantas untuk jadi clickbait, Pak. Dari judulnya harus kayak lah gitu.
Ya bagus lah mengawali tahun 2025.
Iya.
Biar pada semangat.
Saya sebenarnya
nonton.
baru mulai juga, baru mengajukan proposal, Pak. Akhirnya belajar.
Gitu ya.
Karena
Mana Bu Presiden tadi? Bu Presiden kok nggak terlihat ini wajahnya ini.
sibuk paling.
Ada tuh, tapi nggak
Sibuk.
tahu.
Mau ngomong politik kok
nggak
enak
bisa
ya, ada
nyalakan.
Bu Presiden.
Selamat
Bu
Pak
Leli,
Slamin,
terima
terima
kasih
kasih
ya.
banyak.
Makasih banyak banget Pak Edi. Oh, thank you so much.
Ya, doon ya Pak Slamin ya.
Terima
Oke.
kasih.
Oke, saya tutup ya.
Terima kasih
Yo,
semua.
Mari
bye.
sampai
Saya izin
ketemu
Ya,
semua.
terima kasih Mbak
Juga.
Dewi.
Yuk.
Thank you.